This is Excite Systems Corporation, and we've set up a demonstration here today of one of our Excite 1100 exciters. It's in a rigid test frame so that we can run high force, low motion control. You can see the exciter head is sitting here, the load cell is on top of it, and the load button. When we turn the exciter head on and we put it into static force, the load button will come up and the piston will engage the test structure and we will start to generate some static force. Okay, what we're going to do now is we're going to start the hydraulic power supply, and we're going to energize the exciter head so that we're now able to turn the exciter on. We'll now ask the exciter, by using the master controller, to go to static force of 1,000 pounds. And when we turn the master controller on, you can see the piston has come up. It is now pushing against the structure and is now generating 1,000 pounds of static force. This is the master controller that we use to put the exciter into static force mode. It has a static control on this side, a dynamic control on this side, pump control, and other settings down here. So the first thing we're going to do is repeat what we did with the exciter, and we're going to start the hydraulic power supply in order to get the exciter to be able to go into static mode. We've now started hydraulic power supply, and now we will put the exciter mode from standby into static mode. And the piston will go up as we showed in the earlier video. And you can see the meter is now up at 1,000 pounds. We've asked the exciter to produce 1,000 pounds. All right, now we're going to show what the forces look like going into the static mode. So you've seen the hydraulic controller. We're now at the scope, and we've just put it into 1,000 pounds of static force. This is 0 here. This is 1,000 pounds here. It's 250 pounds per division. So we've now gone ahead, and here we'll go back to standby mode, and you can see the force has gone to 0. And we'll go back to static mode, and you'll see the force has come up and is sitting at 1,000 pounds. Okay, we are now back at the test stand with the exciter head. The exciter is in static mode, pushing 1,000 pounds. We're now going to turn the master controller knob to dynamic and ask the exciter to produce 1,000 pounds of peak force. So now we have now turned it on, and it is generating 1,000 pounds of peak force. And you can't see it very well here. We'll look at it on the oscilloscope in a moment. But the unit is pushing with a preload of 1,000 pounds, and then a sinusoidal signal at 1,000 pounds peak on top of that. The master controller now is in the static mode, as we've explained before. We're generating 1,000 pounds of preload. This is the dynamic control side of the master controller. I've set the amplitude to request close to 1,000 pounds of peak dynamic force. In order to get the peak dynamic force, we're going to turn the knob from static to static plus dynamic, and the meter will then move up to the force that we want. And you can see here, we've now gone into static mode, and the meter has moved up to just about 900 pounds of peak dynamic force.
Okay.
All right, we have now reset to static only. You can see on the oscilloscope, again, this is 0 force. The dark line is 1,000 pounds of preload. I'm going to start the dynamic force again, as in the last demonstration, by turning the control knob from static to static plus dynamic, and we're set the frequency right now at about 12.5 hertz. You can now see that there is a sinusoidal force frequency. From this point to there is 1,000 pounds peak. So here is 0 force, here's 1,000 pounds of preload, and we have 1,000 pounds of peak, and then we go negative 1,000 pounds. So this is swinging back and forth, 2,000 pounds of force. I'm going to change the frequency now. We're at 12 hertz, and I'll start to take the frequency of the exciter up. Now we are up to about 60 hertz, and I'm going to expand the oscilloscope so that we can see the waveform better. That's 60 hertz, and now we'll continue to sweep up in frequency. We're now at 100 hertz. You can see the force is staying constant at 100 hertz. Now we're going up. We're now at 160 hertz. We're now at now we're up to about 200 hertz. You can see the force is staying constant. We'll continue to sweep up until it starts to roll off a little bit. We're now at 300 hertz. and we're continuing to sweep up. We're starting to roll the frequency off a little bit because of the dynamics of the structure. We're now up to 400 hertz. All right, we're going to rerun the frequency sweep test at this point in time, and we're going to now start the exciter. It's at 12 hertz, and we're going to sweep the exciter up to 400 hertz. You can hear it as it's sweeping. I've got my finger on here. You can feel a little vibration. The exciter head is sweeping in frequency. The structure, of course, is stiff, so it's not moving that much, but it's now sweeping up, and it will be at 400 hertz, and then that's where we will stop the test. All right, I have now loosened the bolts that are holding the top of the stiff structure. I'm going to remove this so we can run the exciter head in what's called free mode. So the bolts are loose. I'm going to lift off the test top structure, and then we will be able to watch the exciter when it's in free mode. All right, we're ready to run the exciter in static displacement control. When we put it in static displacement, we can make the piston come up to any position we want in the 1-inch stroke. In this case, it has just come up to a ½ inch, so it's exactly in the middle of its stroke. You can also vary that amplitude, and you can put the piston in a static position any place from all the way at the top of the stroke all the way down to the bottom of the stroke. This allows you to position the piston in a static mode in order to position it under the test structure. All right, we're back in standby mode. The piston is fully retracted in displacement control, so we're going to go back to static displacement and come up a ½ inch. Well, you can see the piston is now up a ½ inch. We're now going to use the dynamic portion of the master controller and ask the exciter to start moving up and down at 1 hertz frequency, just 1 hertz, and of the full 1-inch stroke. So here you can see we're now running up and down at 1 hertz in free air, and now we will take our oscillator and start to sweep our oscillator from 1 hertz up to 50 hertz. So if you watch the exciter, you can see it's increasing in frequency, and we're sweeping the frequency in free air up to 50 hertz. We will stop the test at 50 hertz. This is 50 hertz, and we could go higher in frequency. We'll come back down in frequency and see if we can sweep it down. You can see as we go down in frequency, the amplitude gets much greater. All right, we're going to look at the oscilloscope, looking at some of these displacement signals that you just saw on the exciter head. At this point in time, the master controller is set in standby, and the piston is completely retracted. So the first thing I'll do is I will turn the static control so that the piston goes to mid-stroke. You can see it went from there. It's now at mid-stroke. So that's at 1/2 inch, because we can swing plus or minus a ½ inch. So once we're at mid-stroke, as we shown early, we will now go to the static plus the dynamic, and we will look at the piston moving. You're now looking at the actual displacement of the exciter, and it is moving plus or minus a ½ inch or 1 inch from here up to there. Our frequency is 1 hertz, and we're moving at the full stroke of the exciter of 1 inch. I will now repeat the same test that we did before, where we swept the frequency up to 50 hertz. You'll see the displacement go down as we sweep up in frequency, because the exciter cannot maintain a 1 inch stroke at extremely high frequencies. So now we're starting to sweep up, and you can see the displacement is continuing to go up, and we're moving up in frequency. We're now at 30 hertz, 35 hertz, and now we're up to 50 hertz. And that is a good indication of the displacement. We can sweep back down and see how the displacement changes as we come back down, because we're in free mode. And we'll go back down to about 1 hertz. And that is 10 hertz, and now we are down to 1 hertz. This is the 1201B hydraulic power supply, which is used to drive the hydraulic exciter that we've looked at earlier. It has an array of buttons and switches that gives the condition of what's happening in the pump, including the oil over temp, low oil, the voltage applied, the filter, and also if the phase is correct. There's also an hour meter. So this is the pump. It is remotely controlled from the master controller. We'll show that in a moment. The internal power supply, the 1201B, is assessed by two doors that swing out, and you can see the inside of the power supply. This main box here is the reservoir where the oil is kept. This over here is the heat exchanger, which takes the heat out of the oil, and then the components for the rest of the supply are up in here. This is the filler cap for to put the oil in. This is an indicator gauge of how much oil is in it. And up here we have a filter, and in the back is the motor. The pump, the actual pump, is inside of the tank. This is an accumulator on this side. So this is the internal workings of the hydraulic power supply. All right, we're now going to go ahead and start the hydraulic power supply and bring it up to pressure. So as I said before, you can start the hydraulic power supply by pushing the pump start button on the mattress. The pump is now turned on and it is running and is generating 3,000 psi of pressure. And we will now take some noise measurements to show you the noise level of the pump. We're using a noise meter to measure the noise of the pump at a distance of 3 feet from the front. It's measured a little higher right now because I'm talking, but we're going to zoom the camera in, and I will stop talking so you can see the noise level being generated by the pump at 3 feet. And you can see it's running at 74 dB. This concludes our little demonstration of an Excite system and the way it works in both force and static control, and also in dynamic force control. And we also have looked at displacement, both static and dynamic. And we've also looked at the power supply and the noise level of about 74 dBA from 3 feet in the front of the cabinet. So from this, we hope you'll be able to have a better idea of how the Excite system works and what it can do for your testing requirements.